Hi everyone. So this is the ABO-RH experiment. As you can see, there's 5 blood samples and there's little vials for each blood. These are 2 of my kids and I had them do the experiment. I had them put Kim's blood in the one tray, then Andrea's blood, then sample 1, 2, and 3 in each different tray. And then on the trays, on the top one of every tray, you put anti-A serum. And then on the bottom one, you put anti-B serum. And then on the side, which you'll see in a minute, you'll put anti-D serum. Now, if you remember, if the person has an antigen in their blood and the antibody is there, it will combine and it will agglutinate, and that means to clump up. So it won't be smooth looking like regular blood. So that's what this is doing. This is determining what is causing agglutination and what is not. So by combining the antibodies with the different blood types, you can see if it agglutinates with type A, if it agglutinates with type B, or if it agglutinates with type D. And remember, D is the RH antigen and antibody too. Okay, so as you can see, my 14-year-old is much faster than my pretty little princess who just wants to make everything perfect and takes a little bit forever, even on 1.5 speed. So, and of course she has to dance while she is mixing things. My kid. All right, so in a second, you're going to see the results. So this is just an example. The bottom one, what you're looking at right now, has no agglutination. It's nice and smooth. Now the top one, look closely at it. If you look really close, you'll see how it's almost speckled. That's a little bit of clumping. The anti-D almost looks like it clots. You see how it's kind of like thick and goopy, technical term. Either one of those is called agglutination. So the bottom left would have no agglutination. So here are the results. Here's Kim's. So this is the first mom. So we did 2 vials for her. So there's A, B, and D. Again, A, B, and D. I spread the B around just so that way you can see a little bit more if there is any kind of agglutination or not. But you have to determine what you're looking at here. Next is Andrea, the second mama. So this one's a little bit easy to see where there is clumping or not. A, B, and D. A, B, and D, just to make sure you guys understand. And then we're going to look at the babies. Sample baby number 1. Okay, so there's A. Make sure you look at these closely. A, B, D. A, B, and D. Now, I mixed that up because you couldn't really tell how gross and disgusting that one was. So, yeah. Now, baby number 2 is A, B. I'm mixing that up because I wanted to show you how that there is some speckles in B. I don't know if you can see it or not, but I want you to be able to see that, and that's D. So last thing is baby number C, or number 3, and there is A, B, and D, B, A, and D. So there you go. So I know it cut off, but you got the point that it was A, B, and D. So this is the experiment, and in your lab packet will be tables asking about A, B, and D for each one of them, and then figuring out which one of the babies belong to which one of the mommies. So if you are confused with how agglutination works, if you're confused with antibodies and antigens, you can feel free to reach out to me and we can discuss it more on Tuesday during the lab time via Zoom. If there's anything else you need, reach